parameters that are called as rate of descent and a safe height to maintain on a particular glide slope angle. So what is that glide slope angle? What is the safe height we're going to talk about? And we're going to see how to apply the 1/60 rule to determine these numbers. It's going to be very exciting, and it's one of the most easiest concepts in your navigation studies. It is a part of your general navigation, and in general navigation, we can say it is a part of your in-flight navigation. Your doubts on Rishi, where do you stand on your assignment? Yeah, Rishi, are you there?
Yes, sir.
Yeah, where do you stand on your assignments? Have you submitted CPPNR?
No, sir.
Hardik, have you submitted CPPNR?
No, sir, I haven't.
Yes, sir.
Rishi, when are you planning to submit?
I'll be submitting it by today only, like midnight, 12 o'clock, before 12 o'clock.
Okay, fine. Just confirm with me, Hardik, Swati, and Rishi. In class, had we done the CP sums with reduced tasks? A question in the class, had we discussed a question that talks about calculating CP when you have engine failure, that is reduced tasks? Do you think we have done that sum in class?
No, sir.
No, sir.
Negative, sir.
Yeah, so we'll be doing it. Okay, we'll do it in some session ahead. Other than that, you can do other sums. That sum I'll show you how to do. We'll do it when everyone else is there in the class. So put that in the parking lot, okay? Everyone, I think you all have similar doubts. Hardik and Swati, you have asked me similar doubts. So I'll reiterate that once again. So put it in the parking lot, CP sums on reduced tasks, and write today's date in the parking lot. And students, just a heads up, today we will have RT exam session, of course, but we will not have metrology today. We'll have metrology and regulation just tomorrow. Okay. So just make sure you're free and you utilize your time well. So after this, we'll be doing RT, and after that, we'll not do metrology today. Metrology and regs we'll do tomorrow for this week. I don't think anyone else is joining. So we will get started, okay? So Hardik, are you aware about the term called glide slope or rate of descent?
Sir, like I know just the basic meaning.
Tell me, what is the basic meaning that you understand?
Sir, it might be a slope in any like angle or something related to.
It's like a slope during your arrival. It actually guides you to make a very smooth landing, so that you don't make a bumpy landing or a hard landing, and you don't damage your landing gears also. Correct. Rishi, what about you? Have you heard about rate of descent?
Yes.
So what's your understanding?
Rate of descent is the altitude decreasing per minute or so, like that.
Rate of descent could be how many feet will you reduce in your altitude per minute? That is the rate. Correct. Good guess. Swati, do you have any idea about what rate of descent could be?
Negative, sir.
Any assumptions? Please try to make a guess, calculated guess. Yeah, Swati, any calculated guess? What could it be? Swati, are you there?
Yes, sir.
Yeah. Any idea what it could be? Rate of descent? Any guess? Lakshya, welcome to the class. Late today also, Lakshya. What's happening? Why always late? 15 minutes, 10 minutes? And Lakshya, you haven't yet submitted the assignment for CPPNR. How do you read, Lakshya? Quick. reply.
Read 5, sir. Sir, I'll submit by today evening. I have completed the assignments and everything. I have to submit the computer number documents also. I'll do it all together after we are done with the RT class.
Good, good. Just a heads up. Today we are not having a MET class after the RT class. MET and regs will be tomorrow. Okay. So use that time to cover up your assignments. So Lakshya, what do you think is rate of descent?
So
Any
the rate
idea?
of descent is the rate of an aircraft which is losing altitude. The rate through which the aircraft is losing altitude. For a safe landing or a safe approach. Like the vertical speed.
Say again.
So the rate of descent is the rate involved in which the aircraft is losing altitude. Like we can say the vertical speed of an aircraft.
Vertical speed of an aircraft. Yeah, not bad. Good. So you guys are right. Although Swati, you didn't give me any inputs, but it's okay. We will see what rate of descent is first and what a glide slope is. Okay. Just a reminder to everyone, we are doing general navigation related topic based upon the 1/60 rule. What is that 1/60 rule? Now I'll also tell you about the 1/60 rule in general, and I'll repeat this rule a couple of times also in future. 24th June is today's date. So 13 F22. Okay. So topics to understand rate of descent. Okay. Rate of descent. And then we have GS. This GS is not ground speed. This is glide slope. It is always an angle, theta. Okay. And then we have something called as range. Range will be, in this case, distance of aircraft from runway or glide slope. And height. Safe height for a particular glide slope at a particular range. So these are the terms that we are going to be using in this set of lecture or series of lectures. So we might have to calculate glide slope. We might have to calculate rate of descent. We might have to calculate the distance of the aircraft from the runway or the ground speed, glide slope, or the height, which is the meaning is safe height for a particular glide slope at a particular range. The range we already know. In this case, the range would be distance of aircraft from the runway or the glide slope. Now, how does it look like? Okay, I'll make a side view of the runway like this. Okay, if this is my runway, okay, then a glide slope will be, the glide slope antenna will be somewhere here, or there are ILS, what do we say, ILS antennas strategically located. Now I'll tell you about ILS. Instrument landing system. ILS has three parts: glide slope, localizer, and markers. So glide slope gives you a vertical guidance to land on the center line of the runway. Localizer gives you lateral guidance to be on the center line of the runway. And markers give you range from runway threshold. Okay. These three parts, localizer, glide slope, and markers, together make up the instrument landing system. Now, these systems also work on the principles of radio waves. Glide slope will have a separate antenna, localizer will have a separate antenna, markers will have separate transmitter antennas on the ground near the airport, and the aircraft will have receivers on board which will receive the frequencies transmitted by these specific antennas. And then you will have certain indications in the cockpit that will help you align with the center line of the runway during landing. Okay. The instrument generally used with ILS, forget the diagram, we'll come to the diagram again. The instrument used in the ILS generally that combines glide slope and localizer is sometimes called as horizontal situation indicator, or sometimes the CDI also. It looks like this, a circle. In the center, there are deflection points like this. More about it when we do VOR, like this. And then there are vertical points like this. Okay, straight points. Now on the instrument, there will be two white bars. I'm making them in blue. One will be like this, horizontal bar, which will go up or down. It will show you localizer. And there will be another white bar in the center. This will show you glide slope. Correction, this is, I have said it, make the correction. The horizontal bar is glide slope. The blue bar, horizontal bar is glide slope. And the red vertical bar is localizer. So while landing, what pilots do, they have to make sure that on the particular instrument, either CDI or HSI, on a particular instrument, you have to make sure the plus is in the center so that you can land on the center line of the runway properly. Okay, this instrument. So we are going to play with this instrument. We are going to talk about this instrument, but today we are not going to discuss the instrument. We're going to talk about the basics first, not reading the instrument, like text-based questions. So now let's look at the diagram. If this is my runway, okay, then the glide slope antenna will be fitted with certain angle, and the most common glide slope angle is 3 degrees. Majority of the aerodromes work with the glide slope angle of 3 degrees. So what does it mean? It means this is a straight. It means, so if this is the runway center line, this is the straight line from the runway, the ground line, okay? And the angle made by glide slope is this angle with this horizontal, this angle. This angle, theta, is equal to glide slope angle. So you have to first make sure that you understand glide slope angle is made with reference to what? It's with the runway threshold. It means the plane has to follow this blue line, 3 degree line. It is the slope to glide down for landing. It is very important. So whenever the aircraft is here, then for this aircraft, this is the height or safe height as we call it. Okay, at this point. So what is this point can referred as? This point is referred as at a particular range in nautical mile or feet. Now I'll show you when to use nautical mile and when to use feet. So if I give you the range and if I give you the glide slope angle, then there is a formula that will help you tell or help you find out what would be the safe height for the aircraft at this range. If you are on that height, it means you are maintaining the glide slope. If you are not on that height, then probably you might be here. If you are here, then what is happening? You are at a higher glide slope angle. See, this angle is higher than your glide slope angle. Okay, this is not good. It is high. So what will happen when you are high on your CDI or your HSI, whichever is giving you a glide slope indication? Okay, the horizontal bar, because you are high, the aircraft indicator, the instrument for this particular glide slope and localizer will ask you to go down. And the bar would be down like this. The bar being down, it means the glide slope angle to be maintained is down. So you also fly down. As you will fly down, the bar will come, and the moment you reach the safe height, you will align with the glide slope. Okay. In case your aircraft is, let's say the green aircraft is below the safe height. So right now, this is below the safe height because for this aircraft, this is the safe height on the blue line. But the aircraft is below the safe height. So the aircraft will need an indication to fly up by the instrument. So the fly up indication would look like this. So the bar would go up. So it will show you that you have to fly up. Are you all following? Lakshya, Swati, are you following?
Affirm, sir.
Affirm, sir.
So your job as a pilot is to first figure out what is the safe height. For that, we have a formula. And then determine your actual height. Your actual height will be either more or either less. So you have to make those certain calculations. Okay. And then you have to either go down or you have to go up to make sure you're on the actual safe height. If you're on the safe height for that particular range, then you are on the glide slope automatically. Okay, that's the technique to make sure you can land safely using your glide slope or glide path. Glide slope is also called as glide path. Any questions? So let's look at the formula then. Okay, the formula, first I'll tell you 1/60 formula. The basic 1/60 formula, okay? Pay attention very carefully. 1/60 formula say theta is equal to, theta is the angle, angle is equal to opposite when the distance, that is range, is 60. Only up to theta is equal to 20 degrees. This is the rule. Whenever your range has a figure of 60, let's say, for example, glide slope is 3 degrees. Range is 60 feet. Find safe height. Now, this opposite here means height. Okay. Range here means another word is adjacent side to the range. And theta here means glide slope angle for us. So if I use this in the formula, then therefore 1/60 tells me 3 is equal to, I need to find out the height. So I'll write h over here upon range, which is 60 feet, like this. Now here, the equation, now you have to carefully understand, okay? Only up to 20 degrees, when the range is 60, your theta is equal to height. This is the meaning. Height or opposite. So you don't need to solve. Only up to 20 degrees, your glide slope in the example is 3 degrees and your range is 60. If your range is 60, then your theta is equal to the height. So if your theta is 3 degrees, then your height is equal to 3 feet. So when you are 60 feet away from the runway threshold, then your height is 3 feet, equivalent to your glide slope. Okay, so write it carefully. As per 1/60 rule, if range is 60, then height is equal to glide slope. If range is not 60, use the formula below. Now it is not compulsory that every time the range given to you will be 60. So we have to use another formula. What will be the formula? If range is not 60, then the formula is theta is equal to height upon range in feet into 60. Now this is the utmost important formula for your general navigation. It will be used in a lot of applications for VOR and ADF sums also. So if you master this formula, you can easily get a score of around, let's say, 30 to 40. Easily you will get 30 to 40 marks if you are well versed with these formulas. It is that the basics, the importance is of that level for this particular topic. So remember, if your range is 60, then the height is always equal to glide slope. Sometimes such simple questions can also come. But if your range is not 60, then we will use this formula. The other way to write this formula is, in other words, theta is equal to opposite upon adjacent into 60. This holds also true. Okay, where I will make the diagram. This is glide slope, this is height, and this is range. Okay, and the same example in this formula, this is theta, this is opposite, this side is called opposite in a triangle, and this side is called adjacent in the triangle. So I want you to understand in both aspects, not just with the glide path or glide slope and range, but also with the basic triangle formula. Because we use the same, if you remember, we use the same formula in track error angle in the last class also. How many of you all remember? We had solved so many sums. Hardik, Rishi, Swati, you all remember this formula? Track error angle is equal to distance off upon distance to go or distance traveled into 60. It is, isn't it the same formula? Can you all relate with it? Are you understanding the formula? I need you all to tell me individually. Yes, no,
Yes,
maybe.
sir.
Verbally, we are a small batch today, so let's talk to each other nicely. We have a lot of time to take personal, you know.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Any confusion? Study it carefully. Go through your notes. See if you're confused anywhere. Take a minute or two and tell me if you're confused. one of the easiest topics if you understand it. Trust me. I hope you're going through it to ask me any questions, okay? Then Swamini is not joining us today. No questions? Should we solve sums?
Yes, sir.
Swati is saying yes. Hardik, Rishi, and Lakshya.
Yes, sir.
Yes, sir.
Yes, sir.
Now I'm giving you a question. Use your scientific calces for calculations. Write down. And make sure if your range is given to you in nautical miles, then you'll convert it into feet using your CX3. For these sums, you can assume 1 nautical mile is 6,000 feet. But I'll suggest you use your CX3 for conversions. So that is one point that we should remember the unit in the formula. So example, glide slope is 1 degree. Range is 1 nautical mile. Find safe height. Options are 100 feet, 200 feet, 300 feet. Can you solve it, students? Try to solve it and give me your answers in the chat box. Students watching it offline, you will drop me your answers in the WhatsApp message box. Are you able to do it, students? Try on your own. Otherwise, I'll show you how to do it. So, Adi, cross-check your answer. Rishi, cross-check your answer. Lakshya, cross-check your answer. Hardik, I mean, cross-check your answer. So Rishi, Swati, and Hardik, after cross-checking, if you're sticking to the correct same option, then let me know. Lakshya, what are you doing? Are you not solving? Correct. Good job. Correct, students. Everyone is right. How? I have the formula. Theta is equal to height upon range in feet into 60. This is the formula. Theta is 1 is equal to height upon range How much is it with the navigation computer? Hardik, range in feet,
Uh,
1 nautical mile.
Sir, 6076 feet.
6076 into 60. Therefore, H is equal to 6076 divided by 60 into 1. So 1 is just 1. So we are not using 1. So almost the answer is correct. 6076 divided by 60. I get 101 feet. That is equivalent to 100 feet. Well done. This is how you have to solve it. Good job. It's very easy. Okay. Next question solve. If glide slope is 3 degrees, range is 4 nautical miles. Find safe height. No options, just give me direct answer. Quickly. Time yourself. Let's see how fast you can do it. Students, are you solving? Good, good. You can take 1 nautical mile is equal to 6,000 feet also, but then you will get your rounded off answers, and these answers will match perfectly with your options. But if your answers are not matching perfectly with your options, and if there is your answer is a little close to that, a little far away from your option, like few numbers, then that is correct only always. You'll not always get perfect matching answers because some of the answers would be rounded off values. So yeah, please be like Hardik, the doubt that you had shared, the difference between the two answers is very small, what you got and what is in the option. So it's a correct answer. In the option, you'll find mark the rounded off figure only. Lakshya, waiting for your answer. Hardik, Swati, Rishi looks good. Very nice. Come on, Lakshya, why so slow? Are you confused? Lakshya, I'm waiting for you. What are you doing? Are you there? All stations, all stations. How do you read?
Radio 5, sir.
Victor Tango Lima Alpha Kilo, Mumbai ground. No response. Lakshya, you're not there. Rishi, are you there? Swati, Rishi?
Yes, sir.
Yes, sir.
So the answer with 6,000 feet is 1200 feet, and with actual CX3 is 1215 feet. Both are correct. Okay. Now there is a direct formula. For 3-degree glide slopes, there is a direct formula. Now, if you want, you can use the direct formula also, or if you want, you can use this formula also. It depends. What is the direct formula? Theta. And the direct formula is height is equal to 3 into 100 into range in nautical mile. Remember, there's a direct formula where you can use your range in nautical miles directly. And the direct formula is height is equal to 3 into 100 into, it's only for 3 degrees glide slope. It's only for 3-degree glide slope. Remember this. Make proper notes about these two formulas. For a 3-degree glide slope, you have a direct answer. Noted. Lakshya, are you there?
Yes, sir. There was some connection error.
Yeah, I was waiting for your answer for the previous question, example 2. Are you getting the same answer? Did you solve it?
Yes, sir. Yes, sir.
Good, good. So in exams, they might assume an answer with this answer, but I would like with 1 nautical mile is equal to 600 feet. That's why the answers would be rounded off. You can use the navigation computer conversions also. Now I'm giving you a direct formula to find height only for 3-degree glide slopes. There is a direct formula to find height only for 3-degree glide slopes. This is the direct formula. Has everybody noted it down? Use the direct formula to find it out. Find this. If find height on glide slope on ILS approach at Mumbai when range is 4 nautical miles. Now, in these questions, in such questions where glide slope is not mentioned, okay, in those questions where glide slope is not mentioned, you will assume 3-degree glide slope. So you write down note where GS is not mentioned, assume 3-degree glide slope. You remember this point, everyone? Now solve this. How will you solve this? It's a 3-degree glide slope, range is in nautical miles, use the direct formula. What is my direct formula? Height is equal to 3 into range in nautical miles, that is 4, is equal to 1200 feet. Is everyone getting the same answer? Hardik, Rishi, Swati. How about you, Lakshya?
Yes, sir. Same answer.
So remember the direct formula also is handy. Okay. Now this was to determine your height. Okay. Now there will be a combined sum talking about this sum along with your aircraft being below the glide slope or above the glide slope, looking at the instrument. That is what we'll be doing sometime ahead. Okay, today we are not following the instrument, but we'll solve these sums based upon looking at the instrument also. Remember, now this was about finding height. Okay, now you have to determine. Now let me just ask you one more question on this, okay? One second. Write down this. On a 3-degree glide slope, aircraft is 0.14 degrees below the glide slope. Okay. Find how many feet below or above is the aircraft from safe height. Range is 3 nautical miles. So if you make a diagram, what will the diagram look like for this? Okay. Your glide slope is 3 degrees. Let's say this range is 3 nautical miles. Your glide slope is 3 degrees. This is your actual safe height. Your aircraft should be here. But your aircraft, they are saying that it is below 0.14 below the glide slope. It means 3 degrees minus 0.14. That is the angle at which you are. That is the slope angle at which you are on. So 3 minus 0.14. You get 2.86. So you are at an angle, glide slope angle, this angle, which is 2.86. And your aircraft is here. So whether your aircraft is below or above, that you can find out. The aircraft is below. By how many feet is the aircraft below from the actual height? So you'll find the actual height for 3 glide slope, 3 degree. Then you'll find the height for 2.86. Then you'll find the difference between the two heights. That many feet you are below the safe height or above the safe height. Got it, everyone? So what are your answers? Hardik, very quick to give your answer. Not bad. Students, are you able to solve? Give me the actual safe height and give me the safe height and the actual height. And then the difference between the two will be the difference between the aircraft position now and the aircraft position where it's supposed to be. Swati, Rishi, Lakshya, waiting for you. Hardik, cross check. So I'll find safe height for 3 degree. So 3 into correction 3. So I have a direct formula also. Height is equal to 3 into 100 into 3 is equal to for 3 degree will be 300 into 3, 900 feet. See, direct formula is helpful. My actual height for 2.86. Here I'm going to use the formula. 2.86 is equal to height upon range in feet. Range in feet into 60. So 2.86 is equal to h upon 3 nautical miles converted into feet. 3 into on 18000 into 60. So this becomes h is equal to 18000 into 2.86 upon 60. I get 858. Difference is 900 minus 858 is equal to 42 feet. And you already know the glide slope angle is lower. It means you are below the actual height. Okay. Rishi, why is the difference 2 feet, Rishi? Correct your answer.
Yes, sir. Typing error.
Typing error. Okay. Swati, correct. Hardik, very good. Easy, right? Lakshya, very good. Below the safe height. Simple. Very nice. Well done. Very peacefully done. Very nice. I'm very proud of you. Now we will be learning how to solve using the same formula, how to find out rate of descent. Now the rate of descent will be finding out using rate of descent is generally in feet per minute. Sometimes rate of descent can also be in feet per nautical mile. Okay. This is common. This one, rate of descent generally will be feet per minute, but we have a couple of formulas to determine rate of descent feet per nautical mile also. Okay. So we'll take a break and we'll come back after the break and we'll continue from here. How to find out rate of descent using the 1/60 rule. So let's come back at around, let's say 1 to 1.5 hours. 15-minute break we are taking. We don't have much to do. I mean, we have much to do, but it is easy. So come back. Short break till 1 to 1.5. Now, before we go, do you have any questions? Any doubts in your mind about the safe height? About being above or below the safe height? Now, using the formula, you can also determine the range, safe range. You can also determine the glide slope if height and range is given to you. So please don't be surprised if the question is not as direct as we are solving. The understanding should be thorough in your mind. Okay, good. I'll see you back in 15 minutes, everyone. Welcome back, everyone. Are we back? Hardik, Rishi, Lakshya?
Affirm, sir.
Waiting for Rishi, and Swati has left the session. Maybe she'll join. Okay, Lakshya is back. Rishi, are you there? Okay, fine. Good. Okay. So we are going to quickly see how to solve rate of descent, and Swati, how do you read?
Did you find?
First, we'll look at how to find out rate of descent in feet per nautical mile. Okay, this is a one-off thing, so we'll learn it separately. What is the application? The application is to make a good glide slope angle. To make a good glide slope angle, if you want to determine what is the good angle, I mean, the glide slope angle 3 degree, 4 degree, 5 degree is the best angle for you to make. But how do you determine how to make a good glide slope angle? Okay. To make a good glide slope angle, okay, the ROD should be 100 into the glide slope angle, feet per nautical mile. This text that I have given you in the box is a thumb rule. Okay. It's a technique that will be very useful to you for the rest of your life as a pilot. In order to make a good glide slope angle, if you want to figure out that what is my good angle, then you can determine it easily by finding the ROD. And the ROD would be 100 into that particular glide slope. This glide slope is in terms of feet per nautical mile, okay, not feet per minute. If you have feet per nautical mile, then as per your ground speed, you can convert it into feet per minute also. So remember, this is a unique one-off thing, ROD in feet per minute. We can find out as a thumb rule, theta glide slope into 100 will give it to you. For example, for a 2.5 degree glide slope, what will be the ROD feet per nautical mile? 100 into 2.5 is equal to 250 feet per nautical mile. Remember, the unit is very important. Otherwise, by mistake, you might end up doing feet per minute also. Next, for a 3 degree glide slope, 100 into 3 is equal to 300 feet per nautical mile. So this is the easy part. If you want to calculate as per nautical mile, 100 into glide slope, you'll get your answer. Hardik, Rishi, Swati, Lakshya, quick acknowledgements. Are we following? Only Swati has given me the answer in the
Affirm,
chat.
sir.
Good. Good. Now this 300 feet per nautical mile is just like if, now remember this one common logic. If this is your runway and if your range is 1 nautical mile, then this 300 feet per minute is your safe height also. Remember, it is your safe height also. Why? Because range is 1 nautical mile and you have to lose 300 feet per minute for a 3 degree glide slope in this 1 nautical mile. So that is your final height or your safe height. If your glide slope is 3 degrees, then this is 3. If the distance is 1 nautical mile, remember. So such quick answers can also be made. If your glide slope is 2.5 and if this is 1 nautical mile, then your safe height would be 250 feet. Are you following this point, students? Your safe height could also be found out. So now please find out safe height for 2-degree glide slope with range 60 feet, 600 feet, and 6,000 feet. Now, do not confuse this with this formula. Look at this question and apply whatever relevant formula is applicable. Quickly tell me. 60 feet is A, 60 feet. I want the safe height. B is 600 feet. I want the safe height. And C is 6,000 feet. I want the safe height for a 2-degree glide slope. Now, which formula will you use? ROD is not applicable because your range is 1 nautical mile in ROD formula, feet per minute nautical mile. So you'll simply use 1 by 60 formula because the range anyway is directly given in feet. So use quickly 1 by 60 formula and quickly give me the answers to these three. If you're confused, then I'll give you the formula. 2 is equal to height. We need to find out range is 60 into 60. Second one, 2 is equal to height upon 600 into 60. And third is 2 is equal to height 6,000 into 60. Correct? Swati, good job. Everyone was able to use the formula. Why is only Swati giving me answers quickly? Why are the others not giving me answers quickly? Quick, quick. We only have half an hour left and we have to cover a couple of important things. Come on, students. Lakshya, Hardik, Rishi, are you solving? I've given you the formula also. I need answers. What is the safe height? No, I need answers. Good, you're following. I need answers. Good, Hardik. Rishi and Lakshya, I'm waiting for your answers. Quick. Good job. Good. So this answer is 2 feet. Remember, this is applicable. The first option is applicable to the direct also. If the range is 60, then the height is equal to your glide slope directly. That is the basic 1 by 60 rule funda. So because 60-60 gets cancelled, that's why. Here you get 20 feet. And here you get 200 feet. Very nice. Chalo. Now let's calculate rate of descent in feet per minute. Okay. Note, a standard rate of descent is required to maintain a glide slope at a given speed. So now we are going to introduce speed also in these calculations. Okay. This standard ROD can be calculated as per the 1 by 60 rule. Okay. Steps to find ROD in feet per minute. What are the steps? Step 1, calculate height of aircraft when it is in inverted comma when it is 1 minute, inverted comma close, from runway or touchdown, same meaning. I'll show you how to solve in minutes. This height is ROD, that is, this height is to be lost by aircraft in 1 minute. To find range in 1 minute, how to do it to find the range in 1 minute? This point, number 1. To find range in 1 minute, divide ground speed by 60. Simple. Because 60 minutes is 1 hour. Ground speed in knots will be, speed is nautical miles in hour. So you can divide that speed by 60 and you will get your 1 minute range. How much will the aircraft travel in 1 minute? Once you get that range in 1 minute, that range you'll use in the height formula to get your glide slope. So the diagram would look like this. Your glide slope, your range, your height. If your range is 1 minute, okay, not 1 nautical mile, and if your glide slope is any value, then this height is equal to rate of descent in feet per minute. Did you get it, students? You understand? The diagram can make it easily able to understand. So indirectly we are finding height, but directly we are finding height, but indirectly we are getting rate of descent in feet per minute. So see the logic used in these applications, they are just, it's like they're connecting the dots with one common principle and applying it in multiple aspects of your air navigation. Let's find out. Example, let's solve this, everyone. If ground speed is 60 knots, range is 1 nautical mile. Glide slope is 3 degrees. Find rate of descent. Give me your answer, students. Your options are 400 feet, 300 feet, and 200 feet. Quick, quick, quick. It is not that difficult. Answers, everyone? I've not yet got your answers. Why is it taking so long? I've given you the steps. Swati again is the first one to give me an answer. Very good, Swati. Cross-check your answer. Hardik, Rishi, Lakshya, quick. Why are you taking so much of time? Follow the steps. Step 1, convert it, the range into minutes. How will you do it? By dividing ground speed by 60. So step 1, ground speed is 60 divided by 60, you get 1. So your range is 1 nautical mile. Got it? Now, what are we going to do? We are going to use that 1 nautical mile in the formula. Therefore, 3 is equal to height upon 1 nautical mile into 60. 3 is equal to h upon, now in this formula, nautical mile has to be converted into feet. So 1 nautical mile is 6,000 feet into 60. Therefore, h is equal to 6,000 into 3 upon 60. H is equal to 300 feet. What happened, Rishi, Lakshya, Hardik? Were you not able to solve it on your own? Hardik, correct. Rishi and Lakshya, please talk to me. Why are you not responding, students? I'm taking your names in so long. कब से नाम ले रहा हूँ, अपना आंसर दे रहे हो ना, मेरे को acknowledgement कर रहे हो, इतना delay क्यों लग रहा है? At least talk to me, right? If one student, two students are submitting when I'm asking, I'm talking to you, tell me, sir, I'm working on it, I'm calculating, I'm stuck. Give me some feedback. Even your videos are off, right? It's so difficult for me to understand if you're following or not, if you don't talk to me. Are you following everyone?
Yes, sir.
Affirm, sir.
Has everybody got it? Now write down this. Direct formula for ROD for 3-degree glide slope only. Okay, write down this direct formula. So for 3-degree glide slope, we have two direct formulas. For height also, for rate of descent also. So rate of descent in feet per minute is equal to phi into ground speed in knots. Simple. This is the direct formula. This is the direct formula. Now try to solve it using the direct formula. Example, find ROD for 3-degree glide slope at 150 ground speed. Quickly solve it. Use the direct formula. Use the direct formula. You'll find your rate of descent. Because for 3 degrees, we have a direct formula. Again, Swati is first to solve. Students, are you not interested? Are you not doing it? Are you not having fun? Are you doing it because somebody is forcing you to do it? So you should enjoy this. You should be first one. You should be the first to do it. Use proper units, students. Feet per minute, proper units. Lakshya, wrong mathematical calculation. Use a scientific calci. Feet per minute. Yes. Direct formula is telling me phi into 150. I get 750 feet per minute. direct formula for ROD for glide slope that is not equal to 3 degrees. What is the direct formula? Okay, the direct formula is very simple. ROD in feet per minute is equal to phi into ground speed into, so ground speed is G slash S, okay? Phi into ground speed into actual glide slope upon 3. This is the direct formula for ROD for glide slope other than 3 degrees. Okay, so find out using the direct formula. Example, for 5-degree glide slope and ground speed 200 knots, find rate of descent. Now use the direct formula, okay, and solve this. I want you to solve this using both formulas. So solve using first direct formula, second normal formula. So the problem is in normal formula you need range. So the range you'll have to find out with the ground speed divided by 60. But in the direct formula you don't need range. Is it direct formula first answer or what? I'm not sure, students. So solution, direct formula, phi into 200 into actual upon 3, right? Phi upon 3. This is the direct formula. And that is for ROD. So what is the answer to this equation? Phi into 200 into phi divided by 3 is equal to 1666 feet per minute. And solve using normal formula. Excuse me, students. Students, do it using the normal formula. What is the normal formula? First, find out the range for 1 minute. So theta is equal to height upon range per minute into 60. So range per minute would be what? 200 divided by 60. Students, are you doing it? Why I'm not getting answers? Come on. Why are you taking so much long time? And so, Lakshay, your answers are still pending. At least other students have given me direct formula answers. You have not even given me direct formula answer. Now I'm waiting for the normal formula answer. Students, where are you? Are you there or not? I'm expecting you all to respond a little faster now. So phi is equal to h upon 33 into 60. Therefore, h is equal to 33 into phi upon 60. Something is not right. Per minute, right? Something is not right. 33 nautical miles per minute, right? Yeah. So that nautical mile we have to convert it into feet also, into 6,000. Only then we'll get it. Into 6,000 is equal to, yeah, is equal to h is equal to 200,000 into 5 divided by 60 is equal to into 5 200,000 into 5 divided by 60 is equal to 1666.66 feet per minute. So here you would not get correct answer. It's wrong, Lakshya. You'll not get correct answer if you forget to convert your nautical miles into minutes. Correction, your nautical miles into feet. So although you have reduced your answer and you have got 1 nautical mile, that whatever 1 minute worth of distance, that is 33 feet, that is 33 nautical miles. These 33 nautical miles, you have to convert it into feet also. Only then the normal formula is going to work. Swati, your normal is correct. Hardik, using normal formula, what's your answer? I have not got it. Put it in the same chat box, students. Otherwise, it's never in sync, okay? It's mixed. Remember, one answer, please put it carefully in the chat box. Properly. Okay? So, Hardik, you mentioned using normal formula, but what using normal formula? I don't know because it's lost now between other chats. Lakshya, please correct your answer. Rishi, I'm waiting for your answer. Students, please respond. What are you doing? Whether you're doing or not, at least tell me that. Got it, Rishi. So see, the answers are same using normal formula or direct formula. The answer are going to be the same. The small variation is fine. Lakshya, where are you? Please correct it. Please talk to me whether you're doing it or not. I've given you an instruction. In RT, you have learned, students, right? How to acknowledge. Be a little fast now. I already told you we have to cover a lot. Please be a little fast. Any doubts?
Negative, sir.
Negative, sir.
Negative, sir.
Negative.
Yeah, when less people are there, you should talk more. You should make the most out of it. You should be like, sir, it's my personal session. Let's talk properly. It has to be interactive, okay? Only for your benefit. Very good. Now quickly solve this question. Glide slope is 5 degrees. Ground speed is 100 knots. Find ROD. Use any method, I don't mind. Okay. Option 700 feet per minute. 830 feet per minute. 900 feet per minute. Quickly. Be fast. Push yourself. Swati correct. Lakshya correct. Fast, students. Push yourself. Hardik correct. Rishi waiting for your answer. Quick, quick, quick. Good job. Any doubts?
Negative, sir.
No, sir.
Very good. Do this. 4-degree glide slope, ground speed 100 knots. Find ROD. Find ROD in feet per nautical mile as well as feet per minute. Find ROD in feet per nautical mile and feet per minute, both. So I want answer in feet per nautical mile and give me ROD in feet per minute, both. What are the answers? Quick, 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 quick. Come on, students, fast. Now, Lakshya, your answer is incomplete. I don't know if it's number 1 or if it's number 2. Hardik, your answer is incomplete. I don't know if it's number 1 or it's number 2. How many times should I say this, students? Is it difficult? Rishi, I don't understand if it's number 1 or number 2. Now you have mentioned feet per minute, feet per minute, feet per minute. Good. I can see that feet per minute. But then it's number 2 answer, not number 1. So please mention the numbers correctly. Lakshya, your answer in feet per minute is incorrect. Feet per nautical mile, his answer is simple. 100 into the glide slope angle. 400 feet per nautical mile. Rishi and Swati, you got it correct. Hardika and Lakshya have not got your answer. Number 2, ROD, I have a direct formula. Phi into ground speed into 4/3. I can use this direct formula, right? So what do I get? Phi into 100 into 4 divided by 3. I get 666.66 feet per minute. Hardik, nautical feet, ROD in nautical feet per nautical mile.
So just sending. I've done that. Got the
Good
same
students.
answer.
Good. Same answer to what? Write it in the chat box quickly. Quick, 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 quick. Good job. Now quickly write down. Calculate ROD with changing ground speed. Okay. Now, there are chances that during your descent, your ground speed might change due to deceleration or increase due to acceleration. So if your ground speed is changing, then what will happen to your rate of descent? Your rate of descent is also going to change. So your rule of thumb is A, when ground speed decreases, your ROD will also decrease. And when your ground speed increases, your ROD will also increase. First point. So this relation you need in your mind, okay? Remember this rule of thumb. It will be applicable to determine your new rate of descent or old rate of descent. Okay? Formula to use for 3-degree glide slope. The formula is change in ROD is equal to phi into change in speed. So if you can determine the change in speed, which you will know with the question, then that change in speed you can use to find change in ROD. Then if the speed was reduced, then you will reduce this value of ROD from actual ROD. If speed was increased, then you'll add this value in the actual ROD to get your new value. And for glide slope which are not equal to 3 degrees, simple. Change in ROD is equal to phi into change in ground speed into actual GS upon 3. This is the formula that you will use. So what are you supposed to do? Now look at the question. You'll make more sense. Quickly, okay? We have to finish this within less than 10 minutes now, okay? It's not difficult. I want you all to act smart. Question. Question number 1 is in 2 parts. Alpha, ILS approach using 3-degree glide slope. If ground speed is 140 knots, what is ROD required? Okay. Bravo. If ground speed reduces to 120 knots, what change in ROD must be made to maintain glide slope? What is new ROD? Okay, so we'll find solution for 1. Follow my steps. Solution alpha. They are asking ROD for 3-degree glide slope when my ground speed is 140 knots. So I'll use the direct formula. Direct formula tells me ROD is equal to phi into ground speed, correct? Is equal to phi into 140 knots is equal to 700 feet per minute. Correct? Everyone? Yes, no, maybe? Easy?
Yes, sir.
Now, B, I want change in ROD. So my speed is reduced by how much? 20 knots. Earlier it was 140, now it is reduced. So my ROD will also reduce. But right now, I need to find out change in ROD. So change in ROD formula is phi into change in ground speed. What is your change in ground speed? Phi into 140 minus 120 is equal to phi into 20 is equal to 100 feet. Now follow the rule of thumb. If ground speed decreases, ROD decreases. Now, if ground speed decreases, ROD decreases. Therefore, new ROD is equal to 700 minus 100, which was the actual ROD minus the change, is equal to 600 feet per minute. Is the new rate of descent. So change in ROD is also there. New ROD is also there. Change in speed is also there. Any confusion? Hardik is solving. What about others? Good job, Hardik. Swati Rishi, Swamini. Correction. Swati Rishi Laksha. What are your answers? Solve it. Quickly solve it. Only 5 minutes more left. Come on, you can do it. I'm giving you one more question. On ILS approach, using 5.5 degrees glide slope at ground speed 120 knots. Find ROD. Second part of the question, you reduce ground speed to 110 knots approaching runway. What change in ROD will you make to maintain glide slope? What is new ROD? Answers, quick. In one chat, you will write all three answers. Previous question, only Hardik and Lakshya have given me, and Lakshya, your previous answer is incomplete. You have only given me new ROD. You have not given me change in ROD. You have not given me your actual ROD. Are you not solving? Students, I want you all to solve everything that I'm solving. Please don't skip it. And please give me answers properly, okay? I'm saying this for the 5th time right now. If you cannot send answers in the chat box, if it's too difficult for you to type, then you send me a picture on WhatsApp of your solution. I don't mind. I'm waiting for your answers. Come on, quick. Yes, Lakshya, go ahead.
Sir, I was having one doubt. Like we have to use the formula for glide slope, which is not equal to 3 degree, right?
Correct.
And the change in ground speed. Okay, sir. Okay.
Hardik, check what you have written in the chat box. Actual ROD. So my actual ROD would be phi into ground speed into 5.5 upon 3. Hardik, typo error, check. Different students are getting different answers. What's happening?
Sir, that's 1100.
So please correct it in the chat box. Copy paste it with correction.
Yes, sir.
Swati, I think your answer could be incorrect. Check your formula. Rishi and Lakshya, do it fast. Last 2 minutes left. My ground speed was 120, right? 5 into 120 into 5.5 divided by 3. I get 1100 feet per minute, my actual ROD. Swati, why did you not get it correct? Hardik, your answer is correct. Swati, क्या गड़बड़ किया आपने? आपने 5 लिया क्या? Glide slope. Question को read करो. 5.5 दिया है.
Sir, I take 100 ground speed.
Why 100? It's 120 knots.
By mistake. Yes, sir.
Yeah, it's okay. Correct your mistake. Lakshya, actual ROD is correct. Rishi, where are you? Are you solving?
Yes, sir.
So please submit your answers. I like your pace, students. You're building your pace. Very nice. Try to push yourself, okay? Now my change in ROD is phi into change in ground speed. Change in ground speed is 10 knots into 5.5 upon 3. Phi into 10 into 5.5 divided by 3. I get 91.6. I can round it off to 92 feet per minute. Change in ROD. So my new ROD is, as ground speed is decreasing, ROD will also decrease. So 1100 minus 92 is equal to, simple, 1100 minus 92 is equal to 1008 feet per minute. So quick. Rishi, actual ROD is incorrect. क्या ले रहे हो आप? जल्दी चेक करो. Time's up, students. Quickly. Rishi, why is actual already wrong? Check your formula. Talk to me, Rishi. What mistake have you made?
Sir, I have sent you a pic on WhatsApp.
What mistake have you made? Talk about it. I'm telling you the answer is wrong. I'm checking your answer on WhatsApp also. Tell me quickly, spot your mistake. $5.5. Why 5.5 into 120, Rishi? What's the formula? Rishi, talk to me. What's the formula?
5 into ground speed into glide slope upon 3.
So what have you done? 5.5. Why? Correct it quickly.
Yes, sir.
Rishi, why 5.5? Rishi, tell me why 5.5?
Sir, I took glide slope.
But in the formula, it's 5. It's a fixed figure, right?
Yeah, sir.
It's not the glide slope. It's a fixed figure.
Yes, sir.
Make that correction and don't repeat that mistake again. Laksh, what's the doubt? Laksh, do you have a doubt?
No, sir.
Good. Rishi, correct your answer quickly. Swati, what's your correct answer? You have not submitted your correct answer. Quick. Solve on your own. Even if I have solved it, you have to solve on your own, students. Swati, waiting for you. Acknowledge, please. Are you doing it? Are you not doing it? Are you there? Correct. Good. Come on, students. Sometimes try to be fast, be on your toes. We have to practice that. Good job, everyone. I'm very proud of you. Just 2 minutes over and above the time that I had for you. Very nice. You should pat yourself on the back. Please go through it once again before tomorrow's session. Okay. Tomorrow we are going to do 1/60 rule, talking about tracking using VOR and DME. So it's going to be very interesting. So you're going to be in air and you're going to get introduced as to how to navigate using your VOR and DMEs also. Okay, so revise all this once again carefully. Try to give yourself certain questions and try to practice if you have to. After tomorrow's session, I'll give you practice questions on 1/60 rule also. Okay. Do we have any questions? Feel free to ask. And when you're revising, if you come across any doubts, you will drop me the doubts on WhatsApp. And Rishi, Hardik, Swati, Lakshya, whatever silly mistakes you have made, make sure you correct those mistakes and don't repeat those mistakes. Read the formulas carefully. Initially, it can be confusing, so keep the formula sheet open and solve so that you don't make any mistakes. Are the instructions clear?
Affirm, sir.
Yes, sir.
All right, I'll take your leave and I'll see you tomorrow for navigation. Remember, we don't have meteorology today. Only RT in the afternoon for you guys. All the best. Well done. Pat yourself. I'm going to see you soon. Take care, everyone.
Thank you, sir.
Most welcome.
Thank you, sir.
Most welcome.